Hi, we're Group 3, and our project is a multi agent travel itinerary planner, a system that takes a one line trip request like plan 5 days in New York under $2,000 and returns a complete rule checked itinerary with flights, hotel, 3 meals a day, and an attraction for every single day. The output isn't just a draft, every plan is mechanically verified against 13 separate constraints before we hand it back. On the travel planner benchmark, GPT-4 Turbo as a single agent passes only 4.4% of queries on common sense rules, and the final pass rate, where every constraint holds, is just 0.6%, basically zero. Why is it so hard? The model has to juggle hundreds of tool results in one context. The constraints are tightly coupled. Budget interactions with cuisine, which interacts with room rules, which interacts with the flight timing, and one slip of any rule fails the whole plan. So instead of one model doing everything, we split the job across specialists with a verify and repair loop. The dataset. We use the travel planner dataset directly. It's 180 validation queries covering 3, 5, and 7 day trips, both single city and multi city. Each query ships with annotated constraints, budget, cuisine, room type, house rules, transport mode, and a sealed sandbox of flights, restaurants, hotels, and attractions for that specific query. The sandbox is what makes evaluation deterministic. Two systems running on the same query see exactly the same options. So, any difference in the result is the system, not luck. We added one extension, state to city expansion. So, when a query says visit Texas, the planner resolves that to candidate cities like Austin or Houston before specialists start picking venues.
All right, moving on to the system architecture, we have two kinds of input. One is from evaluation CLI and another is Streamlit Chat UI. In Streamlit Chat UI, you first parse intent and then the information is passed to the research node. Research node has access to the tool compendium in which we have multiple specialist agents like transport, lodging, dining, sightseeing, each one having its own special context. And after that, we have an assembler which basically aligns all the tool calls, and then it is passed to budget agent that is basically handling the whole budget constraints throughout the user query that has been passed. Once the plan is created, we have verifier which actually verifies if all the constraints were followed or not. And if it was not followed, then we have the repair router, which actually repairs the plan and then fixes and gives you the right plan according to the user.
Okay, moving on to evaluation, we score every plan on the 13 travel planner constraints, 8 common sense rules like diverse restaurants and reasonable city routes, and 5 hard rules like budget, cuisine, and room type. So 5 headline metrics are the delivery, common sense, and the hard constraint pass at micro and macro, and final pass, which requires every rule to hold. We also track LLM calls, tokens, and latency because a planner that burns 10,000 tokens for a 3 day trip isn't practical. All 4 models share the same tool context, so it's apples to apples. And coming to results, so the baseline GPT-4 Turbo single agent gets 4.4% final pass. Our best Gemini 2.5 flashlight in the multi-agent system hits 31%. That's a 7-time jump using a smaller, cheaper model. So the common sense column also tells the same story. The baseline is at 17% micro, and ours is in the higher 80s or 90s. Also, the hard constraints are lower, high 30s to low 40s, and that's exact like the budget caps and cuisine matching are where every system struggles. The other 3 models cluster at around 13 to 15% final pass, and the scaffolding lifts every model 3x or more. But model choice also still matters.
This is the UI of our project. So here we'll have two options. One is multi-agent and another is single agent, which is a like single prompt. And for multi-agent, we'll have two options. One is multi-agent running in parallel and another is sequential. Like we have multiple LLM models as we have shown. Here we'll have the query. So I have asked the system to plan a trip from Tempe to New York from May 1st to May 6th, like with a budget of 2000. And then here we fetched a round trip of 7 options, and then it collects the data, and then it will be passing to the respective agents. And then here we have the plan.